Okay, so let's be honest. When you're crammed in that middle seat, hurtling through the air in a metal tube, fire is probably the last thing on your mind.
Probably not the best time to think about it, no.
Right. But that's why it's so fascinating. Like, how do they actually make these things, safe?
Oh, they do, and it's amazing, really.
So today we're going deep on aircraft fire protection.
We're going to take you behind the scenes, show you how these systems are designed to not only put out fires, but also detect them early or even prevent them entirely.
Yeah. So let's start with, well, the very beginning, right? Detecting a fire.
Crucial, of course.
I mean, we've all seen those smoke detectors in our homes, but I'm guessing it's a whole different ballgame on an airplane, right?
It is, you're absolutely right. You've got different types of sensors, heat sensors, smoke detectors, flame detectors.
Wait, hold on. Flame detectors.
Yeah. And sometimes even systems that combine multiple types of sensors for extra accuracy. Like, think about it, you need different types of sensors in different parts of the aircraft.
Right, like an engine versus, the galley or the bathroom or whatever.
Precisely. Each area has unique fire risks.
Okay, so let's pick one. Let's talk about the engine, because that just seems, I don't know, that just seems the scariest, right? Super hot, tons of fuel.
Absolutely. The engine is a high-risk environment.
So how do they detect fires in there?
Well, in engines, you often find flame detectors. They're designed to operate in those extreme conditions.
I can't even imagine how they do that.
They actually detect the infrared and ultraviolet radiation emitted by flames.
Radiation.
Yeah, so they act like an incredibly sensitive eye, constantly scanning for any sign of a fire.
So it can, like, see a tiny spark before it even becomes a real flame.
Exactly. That's why early detection is so vital, especially in the engine. Because a fire in the engine can spread incredibly fast. We're talking milliseconds. If it's not caught immediately, it can cause catastrophic damage.
I see. So, okay, let's say a fire is detected. Then what?
Then the fire suppression system kicks in.
Okay, so we've got those red canisters.
Yeah.
Right? The fire extinguishers that we see in the cabin.
Right. Those are for small, contained fires that the crew can handle.
But what about, like, a bigger fire in the engine, or, I don't know, even scarier, like the cargo hold?
Well, for those situations, there are automatic fire suppression systems.
Automatic, like no human intervention.
Yeah. In engines and those auxiliary power units, the ones that provide backup power, they typically use halon.
Halon.
Yeah, it's a very effective fire suppressant.
So why halon for engines?
Because it acts fast and leaves no residue. That's critical in an engine with all its complex parts. Now, cargo areas often use halon or they have these water mist systems.
Hold on, why different systems for different parts of the plane?
Good question. It comes down to the specific needs of each area. Halon, for example, is amazing at suppressing fires, but it's not the best for the environment.
So what are they using instead?
Well, they're looking at clean agents. These have similar fire suppression capabilities, but without the environmental harm.
So, like, what kind of stuff are we talking about?
There are hydrofluorofins, for example.
Hydro what?
Hydrofluorofins, they're a type of chemical compound. And then you've also got inert gases like nitrogen or argon.
Okay, so basically a lot of research going into finding halon replacements.
Yeah, a lot of research. It's a big challenge finding something that's just as effective but also safe and sustainable.
So halon's going away. Any chance they'll use CO2?
Well, CO2 is a good fire suppressant.
Right.
But it's not ideal in an enclosed space like an airplane cabin. Displacing oxygen is a big risk for passengers and crew, so they avoid using CO2 in those areas.
Makes sense. You mentioned water mist being used in cargo holds.
Yeah. Well, for one, it's much less hazardous to people and to the cargo itself. Plus, it's really cool how it works. The system sprays a super fine mist of water.
A mist.
Yeah, not like a regular stream of water, a mist. And because the water droplets are so small, they have a much larger surface area.
Okay.
So what that means is the water can absorb heat much more rapidly.
So it cools the fire down faster.
Exactly, leading to quicker suppression.
Clever, right?
Very clever.
So we've talked engines, cabins, cargo. What about all the other nooks and crannies of a plane, like all the wiring, the battery compartments?
Yeah.
Those got to be a fire hazard, right?
Oh, definitely. And those areas need special protection.
So, like, what do they do?
We'll take battery compartments, for example. They pose a unique risk because of those lithium-ion batteries.
Oh, yeah, those can be pretty volatile.
Right. And if they catch fire, they can be explosive. So battery compartments often have their own dedicated fire suppression systems that are super fast acting.
Wow. Okay, so even the wiring and insulation, I mean, that stuff's got to be fire resistant too, right?
Absolutely. They use fire-resistant coatings on cables and insulation to stop the spread of flames.
How's that even work?
Well, when these coatings get hot, they form a protective char layer, kind of like a barrier, which slows down the fire.
Hmm. I'm realizing that there's a lot more to this than I ever thought. Like a whole hidden world of fire protection going on inside every plane.
Right. It's pretty incredible how much thought goes into it. From the sensors to the suppressants, special protections. It's all meticulously engineered for redundancy and a rapid response.
And it all works together to, well, to save lives.
That's the goal.
So the next time I'm on a plane, I'll definitely be thinking about these systems working silently in the background, keeping us safe.
I think we all should. But, even with all of these advancements, fire is still a serious threat in aviation. And it makes you wonder, how do they affect the design of the aircraft, the
Yeah.
weight, every pound counts when it comes to fuel efficiency. And what about the future? What new technologies are being developed to make flying even safer? Those are some things to ponder.
Well, thanks for taking us on this deep dive into aircraft fire protection. And for everyone listening, we hope you learned something new today. And maybe next time you're on a flight, you'll give a little nod of appreciation to those unseen heroes working hard to keep us safe in the skies.